All right, let's get started. Thank you, everybody. This is the Yoshida report, and you're joining our panel discussion on the human factor in aviation and vehicle autonomy. My name is Bolaji Ojo, publisher and managing editor of the Yoshida report. So I'll get started by introducing the folks that we have invited to speak with us and answer the questions that our audience may have. I'm going to start with Mike Lenné. He's the Chief Science and Innovation Officer at Seeing Machines. He's going to be joined by Matt Gray, a former airline captain with Qantas Airways, and Bryan Reimer, research scientist at MIT's Agelab. My colleague Junko Yoshida is also going to be joining as a moderator of this event. Now, just some house cleaning before we get started. We're going to be taking questions, but we would prefer that you send your written questions on the chat panel, and we will join you in answering those questions. We'll pose those questions to our panelists, and hopefully we'll have enough time to answer them. Any questions that are not answered today, we will make sure that we get them across to our panelists and give everybody a feedback on those questions. Now, I mentioned Seeing Machines earlier on. Well, I want to thank them, especially because they are sponsoring this particular event. So who is Seeing Machines? They are safety focused, both in the air and on land. So the best way to describe them, just let's be a little bit formal. So I'm going to say they are a leading driver and occupant monitoring system technology provider. So they are focused, like I said, on safety across all modes of transportation. So thanks a lot to Seeing Machines for sponsoring this event. Now, with that behind us, let me get the microphone over to Junko to get us started. Over to you, Junko. Thank you.
Well, this is the web panel, actually, I have been waiting to do for a really long time. So we are so happy to be able to team up with Seeing Machines on this. Really, the topic on hand here is that we would like to spotlight the relevance of the human factors, both to the aviation and automotive industries. So we hope getting our experts help here to explain how lessons learned by one industry are vitally relevant to another. So I actually want to start with really basic questions. Could each one of you on the panel define what exactly human factor science? Maybe I can start with Mike, because I think you also teaches human factors at a university in Australia. No?
Not for a few years. That was a previous life. But yeah, look, I guess fundamentally, human factors is about understanding people and designing systems to support them. So, perhaps expanding on that just a little bit, everyone who turns up to their work or any activity they're doing brings with them their own experience, their own expectations, their own abilities and limitations. They're doing a particular task, right, which might be easy, hard, long, short, and they're doing it in a particular environment, right? So really, it's about the intersection of the person with the task they're doing and the environment they're doing it in. And fundamentally, we're interested in designing systems that support people. So, let's start with the people at the heart of design. That's probably my elevator pitch on it.
Very good. And I'm going to go to Matt. He is actually the former captain. And I think, Matt, you yourself have experienced the transition within the aviation industry, transition from instrumental clusters to glass cockpit. Can you explain a little bit what it was and what your experience was, and how has that got to do anything with human factors?
Thanks, Junko. When I first started flying, the aeroplanes that I flew on used instruments which were essentially analog. Pilots would call them steam-driven instruments, but they were arrayed in a certain way called a hub and spoke system. So way back in the late 40s and early 50s, Two people who did some research were Fitz and Jones, and they calculated that because of the way pilots scanned the flight deck, the best arrangement was a hub and spoke system with an attitude indicator in the middle with various instruments arrayed around it. So when I learned to fly, that's how we actually got taught to fly, with that particular scan pattern. But now, in my career, over 40 years, instruments are now different. We still do see those analog instruments, but certainly glass instruments now in airliners are far more common, and they're becoming more common in general aviation aeroplanes, because as aeroplanes evolve, they become more visually dense. We get more information in flight decks. So these instruments look completely different. So, and the scan patterns are different for these particular instruments. So we now have to teach and understand a modern flight deck as opposed to what we used to do 20 and 30 years ago. So things have changed quite a bit in terms of how pilots scan instruments.
All right. And that's basically driven by the introduction of flight computer. Is that right?
Well, yes, it is. I mean, aeroplanes now, particularly at airline levels, are hugely complex pieces of machinery. We have a lot of information that is now coming in to a flight deck. We've got advanced automation, and to actually understand that, we have to have far more sophisticated human factors training just to be able to deal with the instrumentation and the amounts of information that we're getting on a flight deck nowadays.
All right. Now, on to the Bryan. Bryan, you are actually at forefront trying to understand how human drivers respond within a vehicle where more and more automated features coming in. Tell us a little bit about what you are actually currently studying. I mean, studying meaning a research of, and how does the human factor come into the picture?
Junko, that's a great question. As part of the AVT consortium, we're really focused on how consumers are beginning to interact with advanced automation in the vehicle. So that's from GM's Super Cruise system to Tesla's autopilot system and the like. And when we think about what Matt just talked about the development of the glass cockpit and the increasing information flow to pilots, we're dealing with an environment where there is advanced training associated, just as Matt said, around the human factors experience and understanding and prioritization of information. When we come down to the consumer level in an automobile, we're assuming that they can figure all this out in real time. And unfortunately, different design philosophies seem to enhance individuals' ability to understand information and react to it. But we have to do this with a level of training that just doesn't exist in aviation. So when we think about pilots, we're thinking about highly skilled individuals who've been taught, trained, have the experience to work with multiple sources of information and make rapid, context relevant decisions. When we think about automobile drivers, we're thinking about everybody under the sun who can pick up a set of keys, turn the ignition on of a vehicle, or push a button these days, a little more automation involved, and begin to go out and drive. And under that scenario, as Mike said, human factors is ultimately critical as the side of engineering most concerned with the psychology of human behavior. So on a really good systems engineering team now, when you're developing a human-centered system, you're going to bring the mechanical and electrical engineers together with human factors engineering. And the systems that really work well are the systems that are designed around the human. The aviation industry learned very early on in the 80s, when there was an increasing amount of complexity of information and automation being deployed in the cockpit to prevent pilot errors, that really the automation best supports pilots. Developing the system around the human and the human's capabilities really leads to their most successful outcomes.
Yeah, well, speaking of which, Mike, Seeing Machine has always stood in sort of at the epicenter of how whether it's pilot or the airplane pilot or human driver, how their eyes seeing things, right? I mean, it's like, can you explain that, what you learn from one industry to another, or that which underpinning technology that made it possible for you to understand how humans scan the instruments and start to grasp the situation.
Yeah, look, absolutely. I think the reason I moved from being a professor in human factors at a university 8.5 years ago to start human factors at a company like Seeing Machines was really around that opportunity, right? It's a shift from tracking the eyes, so classic eye tracking, to operator monitoring, which is almost like taking a whole lot of raw ingredients, like where's someone looking and how's their head oriented, and sort of analyzing that and pasteurizing it into a feature that you can sell, like distraction or engagement or drowsiness. So I think from a human factors viewpoint, fundamentally the ability to understand people is, I guess, a core philosophy across any transport mode. But clearly the approach and the use cases, I mean, a safety use case in automotive is different to a safety use case in aviation. So naturally that has a big impact on the R&D we do. But fundamentally, if you look at a state like drowsiness,
Yes.
That's something that's been around in the subject of research, predominantly in a surface transport automotive context for, I don't know, Bryan, over 20 years, maybe even longer. We're now seeing safety regulations in Europe that are requiring vehicles from the middle of next year to have this sort of class of technology. So that's an example where automotive is leading the way, right? And I was speaking at an aviation fatigue risk management forum last month, basically saying the cars that you drive and your passengers drive to the airport are going to have this technology. The air traffic controllers that control your airspace are quite likely going to have this sort of technology. The trucks on the airport ramp are likely to have this technology. The missing piece here is the cockpit. It's you guys. It's you people in the cockpit. And so I think this is one example that the whole area of interior sensing, I think, is one area that where there have been accelerated developments in automotive that potentially can be that the aviation industry can absolutely learn from.
Sorry, Junko, may I jump in real quick? I just found it interesting. Look, let's break it into two pieces for somebody who doesn't quite get it the way you guys do. There is the human, and then there is the product that comes out of your observations and out of your research and all of that. I think I like Matt to kind of go back in aviation. When you made that transition, you talked about the human factor training. What is human factor training like? What exactly is it that you were taught? What came together before it got to the product end?
Human factors training in aviation has changed a lot. Aviation had to adopt human factors training. And back in the 70s, there were a number of accidents that were with aircraft that were pretty fully serviceable or had a minor unserviceability, but they crashed. And so something was going on. And it turned out that in most of these cases, and about 70% of aviation accidents are human error. So aviation had to change. So over a period of time, we're probably now in the fifth generation of human factors training. But very typically now, as an airline pilot, the human factors competencies, we look for 9 competencies for a pilot, only 2 of which are technical. The rest of them, 7, are non-technical, things like situational awareness, knowledge, decision-making, teamwork, leadership. These are the sorts of things that underpin a pilot's technical training. And the way we train it is we do it in the simulator, is we train these things in the simulator. And they're very, very sophisticated, scenario-based, real-time events where the instructor has to be very well trained in actually understanding what they're looking at, because you'll generally make a non-technical fault or a human factors failing before you make a technical one. So we concentrate now on human factors training. And when I got trained years and years ago in the Air Force in 1980, this did not exist anywhere near to the level of sophistication that we have nowadays. And you'll find that most airlines around the world now are doing this level of human factors training, because in the past we used to just do technical training before, and it is just not sufficient to ensure a safe outcome where human factors training is.
So I think, Bolaji, if I can just chime in here for a second, I think what Matt is hitting at is that one of the myths of automation and a lot of the advanced automation in the cockpit that it's unfolded, the myth is that with automation, you need less human expertise, and it's a myth. The more you automate, the more you need human expertise to interact and support that automation and make appropriate decisions for the context. And that's where the situational awareness training, the leadership training is also important. And I think the automotive industry and the ground surface transportation industry doesn't quite appreciate what the aviation industry has learned over the last 30 plus years about this myth. As we automate, we need to be thinking about how do we support the driver more and more. And that's where, technologies like seeing machines are creating is the sensing technology to begin supporting the driver. We don't know in real time how best to support drivers. We have some good ideas at this point, but there's no optimal. We know that we probably need to be doing more offline training in many of the products than people and consumers are willing to engage in, to understand where and when we use these. How should we prepare ourselves to look around the world a little differently when we're no longer, quote unquote, driving with our hands on the wheel? We have none of this background. But the key being is that by sensing driver state, whether that's eyes, whether that's fatigue, whether that's alcohol impairment, we can begin in real time to deploy countermeasures to help support better decision making. In essence, using the system's capabilities both to automate the path planning control aspects, but also help in real time create the training environment and support the humans making better decisions. Because at the end of the day, we're never going to be able to deploy a training regimen that the aviation or the space industry has been able to develop around consumers driving automobiles.
Yeah, it's almost like the automotive industry kind of jumped the steps. In other words, that the pitch by car makers is, okay, we're going to bring in more automation so that we can prevent people making mistakes, right? So the take the human out of the loop was the mantra. First time when more and more automations coming into play. But what Bryan just said is totally opposite in a way that more automation comes in. We need to understand human drivers better.
So Junko, here's the good news and the bad news. You are 100% correct that yes, the automakers jumped the gun. We're going to develop automation to replace human capabilities and move vehicles around really quickly. And this is going to work. And this was the aviation industry in the early 80s for all the reasons that Matt talked about and some of the crashes that happened in the 70s. But the aviation safety culture very quickly discovered this doesn't work. And you know what? The automotive industry has also discovered that the human factors has become more and more relevant. Folks like Mike and I have been talking about this for some time, but sometimes the electrical engineers and the software engineers need to figure it out for themselves. And we've reached a point where I think that ground surface transportation, the automotive industry has figured out that human factors is important. And many organizations are trying to hire people in these fields faster and faster. And the great thing is that the work we do at MIT is bringing multiple organizations throughout the automotive supply chain, insurance industries together to try to understand some of this together. And we appreciate the support of companies like Seeing Machines and other stakeholders here to work together to understand the unknown. And the foundations here are really critical. If we get this right, we will create a safer, more seamless, more comfortable mobility system. If we get this wrong, automation is going to be rejected and we're never going to see the benefits that it can pursue.
Bolaji, could I add 30 seconds just to your question as well, just from my perspective? But, I think whether you're driving a car today or driving a car in 3 years' time or flying an aircraft, there are different demands put on you as a person, right? If you're asked to do the same thing for 8 hours, your cognitive state is going to change. If you're asked to do a high workload task for 10 minutes, your cognitive state is going to change. So fundamentally, what we're talking about with human factors here, I think, is understanding what demands are we putting on someone at a given point in time? How do we expect them to perform? And how can we design their environment their tasks and systems to support them continuing to do safe performance. So, on the ground, the driving task, right now, we look at fatigue and distraction as, two of the, and if I throw in impairment, 3 of the 5 sort of, safety issues that feature in road safety strategies pretty much around the world. At the core of this is the management of driver attention and cognitive state. And so, that's today, right? So it's relevant now, but I think it's becoming even more relevant, as my colleagues have said here, because on the ground, what we're asking drivers to do is changing with increasing level of driver assistance. So if the driving environment changes and we're asking drivers to do something different, their state, the way we manage their attention, the way they distribute their attention and the way we manage it changes. And I think, as Bryan said, that's one of the areas that, the automotive side has a bit to learn from the aviation side.
And Mike, one of the blessings of being in Europe right now is I've been driving a manual transmission vehicle around. Changing speed limits are vastly different in Europe. It's really hard to pick up your phone in the car and shift and pay attention to changing speed limits at the same time. So, the tipping point in distraction in the vehicle, has a lot to do with our ability to employ automation for power steering and automatic transmissions. So, we reduce workload, and what does the human do? Find something else to do. So we need to be very careful as we reduce workload and manage workload more effectively to make, transportation more comfortable in those 8-hour trips, whether you're in an airplane or in a car. But we can do and use the automation, the AI to do so by creating new activities and new directions and ways to support the driver's attention. But we haven't yet defined what should driving or attentive driving look like as we look forward. What, as Matt said, years ago in the cockpit, there was an optimal design strategy around scanning developed, and the systems developed around that. Do we need something similar in the vehicle? Do we need the research to understand how do we best monitor the world for situations beyond the automation's capabilities?
It's interesting that you guys put all these, and Junko's follow-up question also kind of brought aviation to the roads, right? I wonder though, Matt was saying earlier on that so much information is now available to the pilot. And I think on the road also, we're trying to get so much information also, at least the vehicle is collecting a lot of information also. When you made this switch in aviation, how did you start processing the amount of information that you now have? And what do we expect drivers on our road to now do with the same kind of information now that we're going to be giving them? Look, you've described the fact that the driver needs to be even more involved, but we're also pouring so much more information, just like in aviation, to them. And they're not as highly trained as Matt was.
Well, look, it's exactly right. There is so much information available in flight deck these days, but pilots are trained to say, what is relevant now? What piece of information do I have to look at now to achieve the outcome that I'm doing? There's a whole bunch of other things that are presented to me which are now not relevant. And the only way that we've been able to do it is through practice, through simulation and training to say that piece of information there as displayed is not relevant. You must look here. This is what's going to give you the information for the outcome you are achieving. And it takes a lot of practice to be able to do it. So, and that's why we spend a lot of time training pilots, 16 hours per year in simulators, just to do these sorts of things.
Yeah, I think what you're hitting on, Matt, is also a big gap, because in much of the automotive context, you get your driver's license 15, 16, 17, 18 years old, and the level of training you get after that is zero. We need a lifelong driver education structure globally. We need to move in selected countries like the US from driving as a perceived right to actually a privilege, where we do look at, even moderate amounts of training and continuing education, that can at least motivate and push the system in a more proactive direction. I'm a big believer in that a little information would go a long way, and you're probably not going to get, the average driver to be willing to sit down for 16 hours of simulator training a year too easily. but amazing what an hour might be able to do every 5 years, and at least ensuring that people know what the technologies are around them, know how the environment's changing. And you can no longer excuse, I didn't know it wasn't appropriate to pick up my phone while driving on the highway. No, you were told the last time you got your license renewed.
Yeah, and I want to go back to one thing you did say, Bryan, before about automation, is that automation in some ways has actually increased our workload from time to time. In the cruise, we're not particularly good at monitoring things for a long period of time, but in the cruise, the automation is relatively simple. You're in probably one or two modes. But there've been a number of cases where with poor mode awareness, generally close to the ground on takeoff or landing, the pilot does not know what mode they're in, which has increased the workload, time critical, and has actually increased the complexity of the operation completely. And we've had a number of incidents where automation has not helped.
And you can look at some of the reports on Tesla accidents in the US, and you can see, basically the same narrative occurring on public roads.
Absolutely.
So given that, though, I mean, what Mike told us earlier in this discussion, aren't air pilots being monitored inside the airplane? No?
Are we being monitored?
Yeah, while they're flying.
Yeah, we are. There's a cockpit voice recorder, so that records everything you say. There is also the data stream that comes out of the aircraft, which is the flight data analysis program, which is a constant data stream back to the ground on flight control positions, speed, fuel flow, all those sorts of things. On some of the airplanes that we have now, that if a pilot is not actually doing anything for a while, that you'll get a message that comes up that says pilot response. Something has to be done as a check to see, are you asleep? So pilots are very used to being monitored, not only in the simulator, but actually in the airplane as well, because there's a great deal of data if we had an accident.
Okay. So I think there are a couple of things actually thrown the mentioned in the last few minutes. One is I think that the two things actually I want to focus. One is a mode confusion. I think Matt, you mentioned that, and then there's a thing about degradation in skills. More and more automation comes in. For example, Bryan, you were talking about driving manual in Europe, right? But most people here in the United States don't drive in manual anymore. So how do you square? I mean, how has the aviation industry dealt with? First, let's talk about mode confusion.
Mode confusion. When you change a autopilot mode, you will get what's known as a flight mode annunciation, which will come up. So if I push a button on the glare shield and I change what I want the autopilot to do, I'm alerted on the top of one of the instruments at the bottom, and it will tell me you have now gone into this particular vertical mode or this particular one. And I am required to look at it, and I'm required to verbalize it. Now, there have been studies that indicate that pilots don't actually do that. So, but that's one of the things that we are supposed to do is actually verbalize those, and we get cross-checked from the other crew member to say, yes, we are both in agreement. Now, that's fine when everything's going well and the workload is down and you're not overloaded. But as soon as the workload starts to peak and you get a time-critical problem like a level off or an unusual ATC call or even an unserviceability, your working memory really your capacity shrinks. And one of the things that you will miss is probably the automation mode, because there are a number of sub modes that you can use on the automatics, and some of the sub modes are very subtly different from each other, like vertical speed, which is the vertical speed of the airplane on a climb and descent. Flight level change does much the same thing in a Boeing, but it's slightly different. And you could have something that is completely inappropriate, but because you're trying to do something else, you'll miss it. And now the automation has increased the complexity of the problem and added to your difficulty. That's what happens.
All right. How does the mode confusion how does that work in the or doesn't work in the context of the passenger vehicles, Bryan?
So there's some similarities and there's some differences, Junko. Is that first of all, much like pilots, consumers are visual learners. We look for information. And what we see, first of all, is that when you turn on a mode like autopilot, 70% of the time or so, the driver's looking for visual confirmation that this is on. And we've seen numerous accidents at this point reported in some of the studies where, the driver was unaware that automation was or was not assisting them. It is subtle icon change in many vehicles that disappears, that the automation turns off, but the consumer is not fully aware and appreciative that the automation is turned off, because at the end of the day, the human factor suggests we need visual confirmation. Often there's manufacturers out there now leveraging haptics, alerts in different ways, hitting different modalities to ensure we're aware of the changing, shifting modes. There's some vehicles out there that have restriction modes, like GM Super Cruise is a hands-free driving system. There were some decisions made early on, it appears, to ensure that they didn't offer lateral assistance when hands were on the wheel to minimize mode confusion. Whereas other products developed, been developed in a different philosophy, where like Ford's Blue Cruise, where it has both a hands-on and hands-off feature. One of the worries in there, does the consumer, understand when their hands need to go back on the wheel to support? And that's some of what we're studying. And in many senses, there's been a lot of work and a lot of research put into, how do we try to mitigate the mode confusion issues? But it is an issue. It's going to continue to be an issue because at the end of the day, we are visual learners and we don't necessarily see all the visual information that's put in front of us. We need to be cued, reminded, and supported in new ways.
Will we find a situation where, I know, Mike, this is probably your field, when we talk about AI now and everything is on AI, everybody thinks AI is going to solve all these problems. So all of these issues that you guys have identified, especially the last one set that Bryan talked about, will AI rescue us? Will it take over and just kind of wonderfully kind of sort all things out that the driver doesn't have to worry quite as much anymore?
It's funny because when I joined Seeing Machines, if I had $1 for every time someone said to me, "But Mike, soon there will be no steering wheel or drivers in a car, you'll be unemployed," I could have retired. I'm pretty comfortable. We've got a pretty decent future in this field. So I think there's definitely opportunities to support for AI to support in new ways, absolutely without question. But fundamentally, it's got to be steered in the right way. And when we think about, the mode confusion issues that we've been talking about, and what automotive can learn from aviation in this regard, in addition to what's already been said, there are a lot of modes in driving, right? There's a lot of different interfaces, right? Every OEM has their own way of handling this. How they communicate with the driver. And I think that's this sort of idea about collaboration between a person and a machine is an area that's been sort of well advanced, very mature thinking in aviation for many, many years. There's a small number of aviation OEMs. It's the systems are highly regulated. And compared to that on the road, where, the HMI in a car is one of the points of difference, right? Where the OEMs look to differentiate with different driver experience. But what that means is that the performance during different modes of driving is handled quite differently, potentially in one car versus another. As Bryan said, there's the GM Super Cruise will manage, exposure to risk by allowing it only to operate in certain parts of the road network. So there are fundamentally, it's a wide range of sort of design philosophies in a car. And I think, this is one area where, the road safety, researchers are really scrambling, I guess, to gather information to provide, new data and insights to help guide, the development of these systems sensibly. And dare I say, it's why sort of, step one is, as a basic requirement, let's just understand is the driver, is the driver attentive? Does the driver meet certain basic safety requirements at any point in time? And, you know, if I was falling asleep now, the best way that you'd be able to tell is you look at my face and you look at my eyes and you look at my head droop. And if I, you know, was to look like this for a little bit and go, yep, this is a wonderful, wonderful webinar, you know, you'd probably, the best way to identify that I'm sort of trying to share my intention between sending a text message and the webinar. So, you know, I think as a really sort of practical, silly example, but it's why sort of this approach to understanding people, you know, I think has such a strong future on the ground and in the air.
And Mike, I think you're hitting at there is that we need to be very strategic in how we deploy those countermeasures. We need, you know, the harsh buzzer that you're falling asleep is also the same buzzer you're going to call the manufacturer and say, hey, I don't like my vehicle because it always beeps at me. So sometimes we need that softer motivation, you know, high mount high mount alerts, visual alerts, pulling attention where we want it, but softly doing it before we do it with, you know, using the carrot before we use the stick. You know, how do we ensure that consumers are actually capable of reacting to what we're trying to do, but not just from the safety perspective, from a consumer satisfaction. You know, part of it is this question of what's the risk, what's the benefit, and often the road safety regulatory agencies are all focused on the safety aspect. You know, on the safety side, it's all about, you know, much like the cockpit, sound the alarm bells, get the driver to pay attention now. But that's also, you know, leads to normal poor satisfaction with the vehicle and isn't actually motivating and moving behavior where we want it. What happens is we, you know, if we don't have the aviation safety structure that we have, where you know you're penalized for too many alerts outside of the cockpit, you end up listening and waiting for the alert and then paying attention. So how do we motivate and begin to think about what does driving need to become in the future? You know, I have my ideas, you have your ideas, but we're no longer talking about driving 1950 vehicles where we needed all of our muscle and might to turn the steering wheel prior to the advent of power steering. We're talking about vehicles with an enormous amount of automation and assistance. What is it, you know, what does responsible driving need to look like, and how do we devise the systems to support that? And that's something I think is a shared need across the entire industry, and as you know, is keen to, you know, I personally believe where the eyes are going. But I guess there's probably a couple manufacturers or a couple individuals out there in the world that would disagree with me.
Well, you know, I think Matt said something interesting in the previous discussion. Matt talked about that how in training, in simulation, pilots learn, you know, there's a lot of information in cockpit where to pay attention, right? And this is not very important right now. You pay attention here. We don't have that system in vehicle. And because there is a lot of information inside the this so-called digital cockpit. Now, instead of training human drivers, is it possible or is it foreseeable that car manufacturers to remove the unimportant information from the cockpit? Is that the kind of direction car makers are going? What do you think, Bryan?
Unfortunately, I think there is feature creep because, you know, we're all different. We all want different things. The answer is that we need to ensure that everything exists in the vehicle. I think we see more and more feature creep in there to ensure that we meet the consumer needs. But I think what we need to be thinking about, Junko, is how do we tailor that information to what's needed at a given time, and using the automation and the AI to think about what do I need and making sure that information is relevant. At the same time, I'm seeing more and more manufacturers out there beginning to design the automation in ways that requires the human to do what they should have been doing anyway. Okay, you know, looking at the road before, or looking at a blind spot before you make a lane change, you know, which is in essence filling the gap and ensuring that the driver does not ignore relevant things for the, you know, and over trusting the automation, but is also building the basic skills that are required if you're doing it the old-fashioned way all by yourself. You know, I think one's got to remember that, you know, even the simplest technology such as backup cameras and reverse sensing is automation. It was designed to support drivers, but we see more and more folks looking at the, you know, at the glass cockpit, the picture of what's going on or video what's going on behind you, and backing up without turning around. Okay, you know, how do we ensure we use technology who we have today, and Seeing Machines makes that technology that you're looking behind you and monitoring the world around you, not just trusting the automation. You know, the backup camera is never expected to replace looking behind the vehicle and human perception.
May I ask, Matt, related to what Bryan just talked about, who's the boss here? Is it the automation or the captain? And in automotives, who do we make the boss?
You're asking a captain here. The captain is always in charge, being supported by the automation. You never want the automation to take you anywhere that your brain hasn't got to a few minutes beforehand. So the automation is only as smart as the information that I put into it. So I am ultimately, as the aircraft captain, totally responsible for the automation. The automation is there to assist me, but I really have to know exactly what that automation is doing at the time, and is it appropriate for me to use it now? That's the thing, and that's where the training comes into. But captain is always in charge.
And Matt, you're hitting at words that I think an increasing number of auto manufacturers are starting to understand, but it's taken time, and there's still a number of auto manufacturers out there that don't fully appreciate that at the end of the day, the driver needs to be in charge when the automation is there to support them. And that this allure of highly automated systems isn't so easy. Yes, there are drones up there flying flying drones up there, but there are teams of individuals on the ground supporting that drone.
No, precisely. Absolutely. Totally agree.
Can I ask a question about the skills, degradation in skills? I've heard a long time ago, I was talking to another pilot, and he was telling me about the pleasure of hand flying. On the last day when he was about to retire, he wanted to make sure that he can land the plane before retires. But what's the situation up in the air today, and how that degradation of skills actually happening or not happening, Matt?
There has been a lot of discussion about increased automation causing a manual flying skills degradation in aviation, and that has been studied, and that's probably a fair call, to be honest. The trick is when is it appropriate to hand fly this aeroplane, and when should I use the automation? Now, my experience is that every takeoff is manual, and the automation normally goes in at around about 200 feet. So as soon as you get the automation in, your workload decreases. It gives you lots of opportunity to monitor weather and track and ATC and things like that. Now, the aeroplane is perfectly capable on Airbus and Boeing to land itself, but for 90% of the time, we will hand fly. And we only use automation for things like low visibility, where we have to, because there's just not enough visual cues to be able to do it. So we normally do it that way. Now, that's up to the individual pilot whether they choose to do that. Now, in most cases, they do. The way we get around it is that we design simulator sessions that has a manual flying technical component to it. So we'll do half the session as a human factors, evidence-based training, scenario-based thing where we're looking at thinking, which has technical skills built into it. And the second half of the simulator session will be technical skills only. And we're just looking at the tech skills: landing, takeoff, engine failures, fires, stalling. In particular, stalling is one thing that we do very often. So we dedicate a lot of time to technical skills that are relevant for very, very time-critical and essentially risky maneuvers, such as engine failures, engine fires, things like that. So we do actually practice it. And I have to say that that's probably been a bit of a change now that we're looking at both the techs and the non-techs to make sure that we don't lose that skill. And the lesson plans that I run say, you must fly this by hand without the automation. In fact, if you do fly with the automation, I'll fail the automation on you. It's cruel. It's cruel,
right.
But
it is interesting though, isn't it? Because listening to Matt now, effectively like over 90% or 95% of the flight is automated, right? So when we think about what's happening in a car, like how long is it going to take us to get to that point, right? So right now, where are we now? Even with a fairly open or a more open system, like Tesla, what is it? I don't know, Bryan, 50%? I'm not sure. On the sort of more mature and well implemented systems, it's probably 10, 15, 20% possibly of all trips that you
But it's supported, not even automated.
Yeah,
So,
absolutely. Yeah. And so, the question is, I think we've got a little bit of time to plan this in, properly in automotive and take some of those lessons. But it is going to be a challenge, not so much for people that already know how to hand drive, so to speak, but for people who are learning to drive in a fundamentally different environment, it's going to be different.
But Mike, look,
if consumers, go ahead.
So one of the things that concerns me the most is that we are vacuuming out the skill requirements for driving without a perception of how we're going to replace and support this. So, driver skill, driver situational awareness is really, probably at an all-time low. So, you go ask the average consumer to parallel park a car, again, just a simple activity that you even test during licensure. Most folks can't do that and avoid it. So we need to think about, we are, creating and vacuuming out the skill requirements, which means that the capabilities of the driver today are looking more and more like novice drivers. And there we understand the risks pretty well. Novice drivers get into a lot of mistakes because they haven't developed the expertise to avoid that. And what Matt's talking about is in the aviation safety culture and the training side, you're training that expertise and building it. And this is where this quandary of automation comes, is as we automate, it requires more skill. But if we're not building that skill through either off-board training or I think we need to be moving forward more onboard training, how do we expect what do we expect the outcome to be? Well, what I do is probably more risky roads, actually. So we need to be thinking, I don't think we can think wholly in off-board training with consumers and vehicles. I think we need to think about a little bit of off-board training, but how do we use the systems to, in essence, train the individual? And this requires getting the computer scientists and the AI engineers all together with the folks who understand humans and developing much stronger human-centered systems, which means we need a lot more human factors engineers and psychologists in our design and development pipelines than we have today.
You guys need to remember one thing, though. In the end, companies are out there to make money. And if we focus on training the driver, then how is same machines going to make money? How are you making money? What are you producing that's going to facilitate this, or that's going to make it possible for automatic manufacturers to continue to make money? That's what they are in business for.
Bolaji, I'll be honest with you. If you develop a really good human-centered system that builds your expertise while you're using it, provides the comfort, convenience, and safety, people will pay more money for it. So I think it can go together, but it requires building the technology from the foundations of trying to support the human more effectively. Drivers, don't have a problem of learning to do things in a way that supports their skill growth. It just has to be threaded into the everyday activity strategically. It's almost like, how do we get someone to eat a little healthier without telling them to eat healthy?
So I'm going to toss it back to you again, Bryan. I'm going to ask, you talked about the technology. So what are those technologies? What, do you have, you and Mike should be able to give us a list of those things that you believe are just critical.
Look, I think GM in the development of the Super Cruise product, hit the nail on the head really well as a first generation automation system.
Okay.
What did they do? They built a high steering wheel mount LED illuminator to drive to cue the driver's attention softly to look at the road when you're looking down for too much. What do they train you to do? To keep looking up. And they did so softly. Okay. And then if you don't follow that, there's a whole cascading alarm piece. But what people do is that, hey, this thing's reminding me to do something I know I need to do. Very rarely do you see the cascading effect being deployed. We kind of are happy to be supported, but we need these taps on the shoulder. Hey, go do what's right. Hey, go do what's right. And we begin to train people. Now, do I think what GM deployed is optimal? No. I mean, we see a lot of people doing this in the car still. But that's a second generation easy fix if we're looking to improve the technology. And we do learn as humans, but we need to be taught. The assumption that we can just figure it all out just doesn't work. So as through the design process, we begin to think about what is the outcome we're looking for, and how do we want to ingrain and build human expertise and how they're looking at the world, how they're trying to stay awake, ensuring that they're getting in the vehicle equipped to make the decisions and have the situational awareness they're needed. We got to be thinking about, what is the outcome we're looking for, and how do we want to support that? How do we reinvent what driving needs to become, as opposed to trying to support what driving was? And this is a give and take here. The regulators many times say, no, the technology is too complex. We don't want to go there. Stop this. We want to stay where we understand. But at the end of the day, if we set our design targets and we begin to think about how do we reinvent driving, much like the aviation industry, as the cockpit changed in the 80s, began to reinvent what training was, what the supporting infrastructure was, what pilot skill needs to become, we can move forward very much more proactively. And I'll also call out that I think we need to be thinking about this across the globe in a global regulatory perspective. If Boeing aircraft were flown differently in Europe and Australia than they were in the US, we'd have more complexities. So, the more we can look for global standards, and I'm a big fan of what Euro NCAP is doing, to push safety standards, and wish the US would just wholeheartedly adopt Euro NCAP, making it a little easier to develop products across the Atlantic Ocean. We can go beyond that later on. But, the easier we make the design development process globally, the more the economics of scale will allow us to deploy technology and make better decisions over the long haul at a cost point where the manufacturer can both sell a product and make the revenue stream that they have to if they're going to deliver products that of value to the market.
But at the heart of that, all of that, Bryan, is how attentive is the driver or operator, and what is their experience with? Are they having a safe experience, and are they having a positive driver experience or operator experience? Because if it's not safe, the star ratings and the safety approvals won't be there. And if it's not a good driver experience, they won't buy the vehicle.
Absolutely. And it all can fit together, but it all comes about how do we support the human more effectively?
Yeah.
Right.
It's not this old technology. Let's build the technology and people will figure it out. That's automotive design from the 80s and 90s.
You're saying human factors is important, Bryan.
Yeah. At the end of the day, it's becoming increasingly appreciated in the automotive industry how important it is. We're just 30 years behind the aviation industry.
Matt drove now. I think Matt, you said he drove about 3 hours today, so that you could attend this discussion. And I was just wondering, I've flown, but I've never flown an aircraft. You have. So when you compare flying up there with driving your car this morning, and we want to bring knowledge from one to the other. So I'm just kind of curious, how was it like this morning for you as you were driving compared with flying up there?
Well, I'm glad you've asked that.
The two vehicles, so to say.
Well, let me answer this by an example. So if I went to drive to the airport and I'm flying Sydney, Melbourne, Los Angeles, JFK in New York, and it's wintertime in New York, there's all those complexities. The most dangerous part is driving to the airport and driving home. And it is the most dangerous because I'm operating in an environment in aviation that is regulated, it's trained, and we've worked to a large degree to take variables out. So we're all properly trained. I know what the person next to me is going to do. I know what air traffic control is going to do. I don't know what the person next to me in the next lane is going to do and what their level of attention is, the state of their vehicle, what they have seen. It is far more unpredictable, and it can deteriorate far more quickly than aviation, because if something happens in the airplane, I pretty much know how this is going to go. I have a checklist for it. I understand the system. I've been trained for it. I've seen it in the simulator, but driving to work, totally different ballgame. Totally different ballgame. Things can rapidly degenerate very fast because I don't know what they're doing. And it was always the most dangerous part of my trip.
Matt, you hit the nail on the head there, is that you think about, we've all been in the situation where we're moving along at 70, 80 miles an hour on the highway. And all of a sudden, everybody's jamming on the brakes, and all of a sudden you're screeching to the halt. And that's why many organizations out there in the automotive industry are looking for connectivity where we can begin to provide better situational understanding. We have the technology to, but the regulatory infrastructure doesn't exist to actually mandate what's needed for vehicles to communicate effectively. So, I'm not an advocate of over standardization, over regulation, but there are areas that the automotive industry absolutely needs supportive regulation. Vehicle communication, attention standards, are illustrations of areas where we can support the driver. And when I think of attention standards, some of the key pieces there are privacy. The consumer wants to know that my information, especially if there's a driver support system in the vehicle, that my information is being kept private, isn't going to end up on YouTube tomorrow. Now, obviously, that's not the intent of any manufacturer out there, but we need to put the privacy check boxes and the checklists, in the design and development process to protect information where it needs to be.
Well, look, I agree with that, and I think the travelling public are very aware, and they are fully supportive of the regulatory environment of aviation. They want it to be heavily regulated, but I agree with you. They don't want the driver environment to have that extent of regulation. They don't want to do that, and it is not appropriate to be able to say, take this regulation in aviation and bring it across here. It will not work.
No. And we don't have the research to support that. And that's, why in many senses, I think we need to be thinking much more in adaptable guidelines. The NCAP system in Europe is a great illustration of this. IHS's safety standards, consumer report testing, all trying to develop goalposts and move them as we get better. Once we fix limit something, the auto industry has a long history of designing to those fixed limits, and we don't see the ultimate safety benefits we can see, or convenience benefits.
Right. Voila.
It has been a very interesting conversation, and we really appreciate your presence, everybody. Our listeners are going to be having questions, which we will be posting to you. We're probably going to email them to you and have you respond to them. Matt, have a safe, nicely regulated drive back.
Yes, I wish I was in the same regulatory environment.
Yes. It's really been a pleasure, Bryan, Mike, and Matt. Junko, thank you always for your guidance on these panels.
All right.
Thank you, guys.
Thank you.
Thanks for coming
Thank
to
you.
the show. This was great. Thank you.
Let me again thank our panelists, Mike Lenné, Chief Science and Innovation Officer at Seeing Machines, Matt Gray, former airline captain with Qantas Airways, and Bryan Reimer, who is a research scientist at MIT Agelab. Of course, my colleague also, Junko Yoshida, thank you for taking part in this session. And especially our audience, everybody that tuned in, we are grateful for your participation. And like I said earlier on, we will be reviewing the questions that you have sent in and making sure that we get answers over to everybody. I also want to thank Seeing Machines, our sponsor. They've always been a great supporter, and particularly because they're very focused on some of those issues that concern everybody nowadays with regard to autonomy, vehicle autonomy, and safety, of course. Thank you, guys. It's been a pleasure. We look forward to hosting you another time.